What you have in front of you here is the classic of all classic intro to derivatives question that you are not very likely to ever see on an actual AP test, but you are 100% likely to see this on an in-class test or an in-class quiz probably multiple times. What we're being asked to do here is we're given an equation and we're being asked to find the derivative of this equation. But they don't want us to do it in the quick, easy way that they're about to teach you in a few more days. They want you to do it using what's called the limit definition of the derivative. So let's start off with what that is. The limit definition of the derivative, so your derivative f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So we have to use that definition to find out what our derivative value actually is. When we do these problems, we're going to go after two different pieces of information. We're going to need to have an f of x piece to plug into this equation, and you're going to need to have an f of x plus h piece to plug into that equation. The good news is one of those pieces is always going to really be given to you for free. We know what our f of x is. The f of x is just that given equation. That's 5x squared plus 3x plus 1. Where the real fun's always going to come in is determining this f of x plus h piece. And so to do that, this is really just an algebra game here. Function notation works the same no matter what. Whatever I replace that x with right there, you replace every x with it in the equation. We're used to seeing this with numbers a lot of times, right? You've seen this where it's like, oh, what's f of 5? Well, that's telling you to plug in 5 for x everywhere in that equation. The same process works here with an x plus h. It's just far less fun because you're not plugging in a number, you're plugging in an equation. So everywhere we see an x in this equation, we're going to plug in parentheses, x plus h. So out of there, we're going to get 5, and then instead of x, we're going to plug in x plus h squared, and then plus 3x plus h, in parentheses again, plus 1. Now all you need to do is expand this thing out. So we're going to start off and we're just going to multiply this thing out. So out of here we're going to get 5, and then we're just going to rewrite x plus h squared as x plus h times x plus h. Then on the back side here we can go ahead and distribute this 3 into everybody. So we're going to end up with plus 3x plus 3h and then plus 1. Now what you're going to want to do is you're going to want to go ahead and multiply x plus h times x plus h. This is called distribution. It's the technical math term. You've probably known it more often in your life as FOIL. It's usually referred to. We just need to multiply these things together. So the 5 sticks around, and then we're going to multiply it out. So x times x gets us x squared. X times h is going to get us a plus xh. Do the middle, we get another plus xh. And then h times h is going to get us a plus h squared. And then down at the end here, nothing changed with those, so we go ahead and leave that as plus 3x plus 3h plus 1. Before we go ahead and distribute that 5, which is kind of the next move here, you want to go ahead and combine like terms in the middle. You'll always have those like terms. So we have x squared, and then we have 2 of those xh things, so plus 2xh plus h squared plus 3x plus 3h plus 1. This problem is really more of a battle of wills than anything else. It's really not that difficult. It's just time consuming. So from there, we'll go ahead and distribute that 5, and we'll kind of be done with it. So distributing the 5 through there, we end up with 5x squared plus, and then 5 times 2 gets us 10x plus 5h squared, and then the rest of the stuff that we've been keeping with us this whole time. So you'll notice there's no like terms there for you to combine. And what you now finally have is a value for f of x plus h. So we have our f of x plus h. We started off with our f of x given to us for free. And now we're just going to start plugging everybody into this limit definition here. So we start off keeping our limit statement with us. We get the limit as h approaches 0. And now we got to plug in that whole f of x plus h chunk right there. So that's going to be 5x squared plus 10xh plus 5h squared plus 3x plus 3h plus 1. And then the key on this, when we do this subtraction here, because it's minus, you always want to do minus and then in parentheses whatever your f of x is. That's probably one of the most common mistakes, is people drop those parentheses when they plug this in, and that changes this whole thing up. So we put in our f of x, which was the given piece, so 5x squared plus 3x plus 1, and then all of that is just over h. The next move here is always going to be the same. You're going to want to go ahead and distribute that negative. This is why it was so important, because it's minus this whole chunk. So we need to go ahead and distribute that negative sign back through there. So what we're going to be looking at now is the limit as h approaches 0. All this stuff up in the front is going to stay the same. It's, again, battle of wills. You just got to write it all down. Plus 1, and now we distribute that negative. So we're going to get minus 5x squared minus 3x minus 1, and all of that is going to be over h. At this point, this is sort of a good checking point to see if you're on the right track. If you're doing everything properly, this entire f of x piece that you just distributed through should cancel out with pieces up in the front here. And if you've done that, then you know you're on the right track. So we got a positive 5x squared and a negative 5x squared. We've got a positive 3x and we've got a negative 3x. We got a positive 1 and we got a negative 1. So all those things canceled out exactly as we hoped they would and knew they should. Now we just grab the chunks that are left over. So we've got a 10xh, we've got a plus 5h squared, and then we've got a plus 3h sitting right there. Because that happens every time, the next thing that you're about to see happens every time. And what that's going to be is you'll notice that there is an h in everybody on top here. And there always should be. And what that's going to allow us to do is go ahead and pull that h up to the front. So we pull that h to the front. That's going to leave us with 10x from that first one. We had 2 h's here, so that's going to leave us with just 1 h inside there. And then we had 1 h at the end, so we pull that, and that leaves us with just a 3. And all of that is over h. Because that should happen every single time, the next move should happen every single time. You've got an h on top and an h on bottom now, and because these are being multiplied, you can finally cancel those out. That should happen every single time, and you should end up in this situation where you do not have a fraction any longer. And if we've done everything properly now, we go to sort of what I call option 1 of finding a limit, and that's just what I call plugging it in. So you just take that value for h, which is 0, and we just plug it into our limit statement. And so out of there, we are going to get 10x plus 5, and instead of h, we would plug in 0 plus 3. And then simplifying that down, that's going to get us 10x, 5 times 0 goes away, plus 3. And there's our derivative. It took us a minute to get there, and you're going to be shocked once you see how easy it is to get there in a couple of more lessons, because it really is just a 2-second math problem in the future. And that's why I say on the AP test, you're not likely to see this at all. In class, because they want you to run through this process, you're definitely likely to see this on a test and a quiz. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.